Hello, this is my video log for my for the second week of my independent study. This week, the task I had scheduled on the syllabus was to implement entity destruction. Previously, you could destroy individual components, but if you tried to destroy the entity itself, the components wouldn't get destroyed. So to simplify the API, now when you destroy a component, it destroys all entities associated with, when you destroy an entity, it destroys all components associated with that entity, which as you'll see, that simplifies the examples greatly, which it would have the same effect for actual gameplay code. Why don't we just pop open the example code, a chunk of the example code from last week. So last week, this is the code that was creating and destroying a bunch of cubes every frame, and it's largely the same. We still create entities and then assign a transform and a mesh to them every frame. But down here, when we destroy the entities, note that we're not destroying the individual components, we're just destroying the entity itself. But when we run the test, and I can go ahead and do that now, we see that the cubes keep disappearing because destroying the entity now destroys the components. Why don't we go over to Entity Manager to see what's changed. All the changes took place here within Entity Manager Destroy. Previously, all Entity Manager Destroy was doing was this right here, which was removing the entity from the list of live entities and then adding its ID back to the free queue. What I added was an iteration over all of the component managers in the scene, and on each of the component managers I call this destroy all method. If we go to component manager base over here in Gunship includes an entity component manager.h, I've added two methods to component manager base. One is destroy all, which is what's being called by the entity manager, and that's required of all component managers, that they have a way of at any time destroying all the components, or at least marking all the components associated with entity for destroy. And then we have destroy all marked, which actually I do not believe I added this week. I believe I added that last week as part of deferred component destruction. So the only thing I added this week was the component manager base destroy all. And that's all that there was to it. It was pretty straightforward and actually only took me a couple hours to do, and I got that done on Monday. So the majority of my week this week has been spent actually working on profiling. Since I had so much free time, I got started on the comparisons between Gunship and the P2 engine that was used as a starting point for game 377. And over here, I've actually got P2 set up on my machine, and I can run it. And you'll see that I've got the same test setup going on here as I did in Gunship. What I'm doing is I'm setting up a series of benchmarks and stress tests that I can use to compare the two engines, and use them as so I can get some baseline numbers, and I can get some profiling data that I can use to compare performance, and use them to find bottlenecks within the performance of Gunship specifically, but also within P2. And I'll be using that to put together my midterm and final reports. So this first test that I've been working on this week between the two engines is testing how well they handle rapid creation and destruction of game objects. So the test is the same thing that I was doing previously in Gunship, where you create like 10 objects every frame, and you destroy 10 objects every frame, and you just queue it up so that all the objects are alive for a couple frames before they die, just to roughly simulate average case conditions in normal gameplay runtime code. And I added in some timer code I'm using over here in game.cpp in the P2 engine. You can see that I'm using the query performance counter functionality provided by Windows to do get, I believe it provides microsecond resolution on checks. So I'm using that to check all of the gameplay code elapsed time, and then every frame I print it out. And if we go ahead and look at that, we'll see that the main loop in P2 takes about like 1.5 milliseconds on average, we'd say. If we can leave this running and we go back over to Gunship, I've inserted the same performance query code into Gunship around the scene update, and we see that Gunship's loop is somewhere around 2.3 to 2.5 milliseconds. So right now Gunship is running about a millisecond slower than P2 in the average frame update. There is some noise happening in there. I'm not doing these profiling tests under ideal conditions yet, because right now P2 can only be built in debug mode. If I try to build it in release, it fails. So there's some noise associated with the automatic assertions that are being inserted by the compiler, as well as I'm performing a number of assertion tests and other not performance optimized actions in non-release builds in Gunship that I'm not sure are happening in P2. However, there may also be more things happening in P2 that only happen in debug builds that won't happen in release builds that are introducing some noise as well. So eventually I hope to be able to do release builds for both of them and get some more accurate debugging information. So right now Gunship is running a little bit less than twice as slow, or a little bit more than half of the speed of P2. And it was actually, when I started doing my profiling a couple days ago, it was actually much worse than that. It was about the frame update time was about 7 or 8 times the speed of P2. But I was able, the bottlenecks that were causing that were showing up right away. And it turns out that the majority of my performance problems were coming from the way that I was handling Ogre resources. If we look at, actually, why don't we go over to GitHub, and I can show you what I used to be doing for in some of the old versions of the code. If we go to Gunship, go to the custom ECS branch, we go back a couple of commits. If we go back to, let's say back here, we browse our files, we go to, let's say source, components, and transform.cpp. We can take a look at the destructor for the transform component. The transform holds on to this node pointer, which is a pointer to an Ogre scene node. And that's how, with Ogre, that's how you set the position of meshes in the world, and that's how you control the scene hierarchies through these nodes that can have parents and children. And what I was doing is, every time you created a new transform, you would create a new node, and every time you destroyed a transform, you destroyed the node. And in this test of rapidly creating and destroying nodes, this proved to be a bottleneck. Ogre does not handle rapid creation and destruction of these nodes very well. So to fix this problem, I implemented a new component manager type. So previously I had the simple struct component manager. Now I have the pooled component manager. The pool component manager is analogous to the simple struct component manager in that you just template it to a struct type like transform or mesh. But in this case, instead of actually destroying the component entirely, it keeps the component in the array, and then it just keeps track of how many live components there are. So in this case, it's still a vector of the component type, but now we've got a live count. And if we look in the destroy immediate method, it's the same. It's almost the same as in the simple struct component manager destroy. We swap the component that's going to be destroyed with the last live component, but instead of popping it off the array, we simply decrease the live count, so that component stays in there. And in the case of the transform manager, that means that we never destroy that scene node. We only, the next time we ask for a new transform component, we just increase the live count and use whichever one was the next available one, and that becomes our new scene node. And I did something similar for the mesh manager. If we look at mesh.h, the mesh manager is now a completely custom mesh manager. That's because meshes are accessed by key, or by a string name. So instead of having just a single pool that's kept in the same array, I've got an unordered map that associates a pool of these unused mesh objects with the name that they're given. This implementation is not perfect just yet, but in my profiling, it's been much faster than the previous version, and it's not showing up as a bottleneck at this point. So I'm going to worry about improving this implementation at a later time. So the pooling components gave me a big boost of performance. That brought me down to just under 3 milliseconds for the frame update time. After that, there were some other minor bottlenecks, and working on those has got me down to about 2.1. So if I open this up, this is the latest instrumented profile of Gunship that I ran just before I started the video. This is the summary page in the Visual Studio profiler. Visual Studio's got a reasonably good profiler built right into it. I'm guessing most professional developers wouldn't rely on it for their purposes, but it's since I'm new to doing profiling and this sort of thing, it's about my speed. If we look over here, it shows the hot paths of what's going on, and these are the places where most of the frame time is spent. And as we can see, our the scene update is where most is on the hot path, which is exactly what we expect. The scene update is where a lot of the time should be spent, but then a lot of the time is being spent in Mesh Manager destroy all marked, which is called every frame to destroy all the components that are marked for destroy. So reasonably, we would expect that to be pretty high on the list, because we know we're destroying meshes every frame. And then also System Manager Update All is showing up as very high, and that's the level manager is showing up in there. And we can actually, if we switch to the call tree view and we click on, it'll give us spectacle.exe, which is our root, and if we hit the expand hot path button, it'll actually zip us right down to what it was showing us before. And we see here it's a Gunship scene update is where 60% of the time is spent, like we would expect. And if we expand this update all, which it was already expanded, we'll see that it's spending all of that time in level manager system update, which is what's actually doing the creation and destruction for of those cubes every frame. We'll see that it's spending a lot of its time calling entity manager destroy, and 12% of the total runtime is being spent in entity manager destroy, which is probably more than it should be. That tells me that entity manager destroy should be a relatively quick thing. It does. Destroying the entities themselves should be fast, and then destroying when it destroys the components, that doesn't actually do any work for any of the components. The components are all marked for destroy, but that doesn't, which means it just adds the entities to a list of components to be destroyed. So the fact that this is taking up 12% of the runtime tells me that I might be doing something wrong in here. And that'll be something for me to explore soon. Pooled component manager assign, mesh manager assign at 3%. That sounds about right. Entity manager create at 1% of the time seems a bit high to me. 1% of the time isn't a lot, but entity manager create should be really 0. It does almost nothing. So I mean that's a minor thing that might call for some more improvements. And it looks like that's going in an unordered set lookup, which maybe I can improve, maybe I can't. I'll have to see. The more critical path we're seeing in here is mesh manager destroy all marked, which 34% of the total frame time is in destroy all marked. And part of my and that used to be a lot more. Destroy all marked used to be the mesh manager destruction used to be one of the major bottlenecks, and it's performing much better now, but it's still not as fast as it could be. If we look in destroy immediate, which actually handles the destruction for the individual components, we see that, let's see, it looks like erase, the standard hash map erase is taking up a good chunk of the time, 14% of the time. So let's see. If we look in, I'm just giving an example at this point of what I do when I'm doing this profiling work. If we go into mesh.cpp is what we're looking for. We go to destroy immediate. We see we've got this erase method here. So this is taking up a bunch of the time, and it's probably taking up more of the time than it should be. So I'm gonna have to figure out some way to make this take up a lot less time. But yeah, that's what I've been doing this week, mostly profiling and performance work. I was able to iron out a bunch of bottlenecks in Gunship, and hopefully I'll be able to get Gunship and P2 running to a comparable state, and that'll allow me to better compare the design decisions that I made in Gunship versus the ones that were made in P2. That's it. I'll see you next week.